Hello everyone, so now we are going to do Leetcode weekly contest, and in this question what we are required to do is we are required to construct smallest number from DI string, and this DI simply represent D represent the decreasing order of this string and I represent the increasing order of this string. So let us read out the question. You are given 0 index string pattern of length n consisting of characters I meaning increasing and D meaning decreasing. So basically that's what I earlier told, and we are given with a 0 index string num of length n plus 1 is created using the following condition. Num consists of 1 to 9. Basically they are saying that there is some num string which consists of 1 to I and 1 to 9, and that is the thing which we would be required to return, and here each digit is used at most 1. So the thing is that we also need to keep into consideration that there is no duplication, so in such a manner we are required to make a solution. And if pattern of I is equals to I, then that simply means the nums of I is less than nums of I plus 1. And if pattern of I equals to D, then that simply means the present character which is being there, that should be greater than the preceding character. So this is the scenario which is there. So basically, keeping in mind about these things, there are a lot of things which we need to consider before coding this solution. But just think about the fact that how we can do this particular question in such a manner that we can easily able to get a solution like this, because means if all three are decreasing, that simply represents that we can also start from 9, 8, 7, right? But here the answer is being given us into the form of 4, 3, 2, 1 rather than 9, 8, 7. Not 9, 8, 7 but 8, 7, 6. Because here as per the constraint we are just given with this much. Means the pattern length should be equals to 8, not more than that. So that's why we need to think of a data structure or some logic in which we can implement that. I simply thought that we can use some if-else conditions, and after doing that we can go ahead with the same. But that was not solving the first case itself, because if we will be using if-else condition, then at this decreasing point we would have implemented some logic like that. If this particular is less than 8, right, then rather than starting from the 9, then rather starting from 8 we can start from the number itself. But that was not giving us the right answer, because they require something different than what that whole scenario was. And even we are required to use the lexicographical smallest possible string num that meets these particular conditions. So now in this scenario where something is about going into some manner and then going from behind to a front manner, so that simply represents that there should be a structure like queue or a stack should be there, in which we simply push into the same and simply pop out from them. Means whatsoever the last entered number is there, that we could directly choose to come up with this particular position. So that's why we are required to use stack here, and that stack would itself give us the lexicographical smallest possible string. Because the thing is that until we encounter I, till then we will be pushing into our stack, and when we encounter I, then at that particular moment only we will directly make our answer with all those elements which were being there in our stack. So that's the thing we are required to do, and in this case, in this thing only, our D case would be automatically handled, because T is only required at that particular position where we are required to have a particular number which is basically greater than the next number which is about to come. So that's why T would be automatically handled in this particular criteria. Now comes the part that how we are required to code this particular solution. So we would be using a string result that would return an answer, and then we would be using a stack, and in this particular stack we will be pushing all our elements, and how we are required to push all these elements. Now comes the part that if here I equals to 0 and then I less than equals to pattern dot length, means basically we are traversing this particular for checking that I and D condition. Now comes the part that how we are required to push into our stack. So the first element which would be pushed would be 1 only, right? So as we are going at the zero-based indexing, means the strings we are starting from the 0, so that's why the first element which we will be pushing, and we will keep pushing until we encounter I. So first element is now being pushed, right? So first criteria would be that we need to check that if our I has reached equals to pattern length or not. If it is not reached, then that criteria we won't be entering in that criteria. Then this particular would be, and then if our pattern of I is equals to I, that is basically now we encounter that now it is in increasing order. So at that particular moment only we need to keep a check that while our stack is not empty, then in that particular moment we will be directly push our this particular top integer which is there by converting it into a string, and then we will push it into our result, and then we will directly pop that from our stack. So that is the thing which we will be doing again and again in this particular, and then means see, now our stack would be empty because earlier it was having just one element with it, right? So now while we would be pushing into our stack, then our I would have been increased and it would be increased to 1, right? So 1 plus 1, 2 would be there. Now 2 would be pushed into our stack, right? So that's why we will be again encountering this increase when we will be encountering. Then at that moment we will push by converting it into string to our result, and like this we will go on. So now comes the part that when D comes, okay, now both of this if condition does both of the condition which are written into this if are not satisfied, right, and D comes up. So till then it will just go into our stack, push and then push and push. It will go on until it encountered a I, and then at that particular moment it will, when it encountered a I, then at that moment it will check that what is at the top. So from there it will go on from in decreasing order. See, in this first example itself, this is the condition which I am talking about. When D was encountered, then it simply pushed into the stack, and then again it pushed into stack, and then it saw that I is there, right? So then only at the top 5 would be there, it pushed into the result, and then 4 was there, it pushed into the result. That is the thing what I am saying. And then now all D's are there. So for handling this particular case, when at the end there is no I, I've written this particular condition that if I equals to pattern dot length. So in this particular criteria, whatever was earlier stored in the stack, then that particular would be directly pushed into a result, and that is the thing which we are doing here. So this was all for this particular question. So now comes the part, the time complexity and the space complexity. So the time complexity is basically order of n, and the space complexity is also order of n. Why? Because the thing is that we are just pushing, we are just traversing our order of n pattern string, and the space complexity is order of n because we are using this extra space from due to the stack. So that's the whole criteria why we are going ahead with the same. So this was all for this question. If you have any doubt, you could comment it down. Thank you.